Dear students, now we are going to see the buck and boost converter, which is also a type of DC to DC converter. First, we are going to see the buck converter. The buck converter that is shown in the diagram. Here, the diagram uses a switch which is connected with the load. Here, we have any one of the device used in the transistor family act as a switch. For example, MOSFET or BJT act as a switch. The diode is a freewheeling diode which is allow the current to flow through it when the switch is turned off. The load used is inductive load. In some cases, a battery is connected in series with the load. Due to the load inductance, the load current must be allowed a path which is provided by the diode. Otherwise, in the absence of the above diode, the high induced EMF of the inductance tends to decrease. This may cause a damage to the switching device. The switch is connected in series and the diode is connected in parallel with the switch. The inductance is connected in series with the load. The timing, the input and output voltage is shown in figure. So here the output voltage that remains a V naught for the duration of T on time, and it remains off during the time T minus T on. And the charging and discharging time of the capacitance is given by the output current I naught. The output voltage is same as the input voltage V naught Vs when the diode switch is in on state. The output voltage follows the input voltage when the switch is in on state. The switch is on for the duration of 0 to T on period, and the time period is called as on period. And from T to T on, next the output voltage is 0. The diode conduction time period is given by T minus Tr. The total time period is the sum of on period plus off period, and frequency is equal to 1 by T. The average output voltage is given by integrating the output voltage with respect to T. So 1 by T into integral 0 to T, V naught into Vt, dt. V naught is equal to Vs, so V naught is replaced by Vs. So the duration is 0 to T on. So substitute this value, we are getting T on by Tt, that is equal to K into Vs. Here K is a positive value. Here the ratio K is not actually equal to 0. It belongs to any one of the positive value whose value is always less than 1. The range of duty ratio is reduced, and here the output voltage is always lower than the input voltage, and the output voltage increases, the duty ratio is also increased. So the variable DC output voltage is obtained from a constant DC input voltage. The load current is assumed to be continuous, and the load current increases in the on period and the input voltage appears across the load. As the load current decreases in the off period, it flows in the diode, through the diode, but it is positive at the end of time period T. The switching device is a thyristor. In the circuit is step-down chopper. The output voltage is normally lower than the input voltage. Similarly, this type of DC to DC converter is termed as buck converters. So next one, boost converter. The boost converter, the switch is also be any one of the transistor act as a switch, and the diode is used in series with the load. That is, the position of switch and the diode is changed compared with the buck converter in boost converter. The load is either inductive or resistive type load. Here the value of the inductance of the load is actually very small. The inductance is connected in series with the input supply. The position of the switch and diode is varied compared with the position of the buck converter. So this diagram represents the boost converter. The switch is on during the period T on. T is between T on to 0. Output voltage is 0. If no battery is connected in series with the load, the current from source flows through the load, that is Is. The amplitude of the current increases linearly with time. That is, the ratio di by dt is being positive. As the current increases, the polarity of EMF is also positive. Vs is equal to L into dis by dt, or das by dt is equal to Vs by L. The switch is off during the period T is between T to T on. At off period is equal to T minus T on, and total time period T is equal to T on plus T off. Here, the output voltage of the circuit is given by Vs is equal to V naught plus L into dis by dt, or dis by dt equal to Vs minus V naught divided by L. In this case, the output voltage is higher than the input voltage. So, contrasted with the previous case, the buck converter, it is also called as boost converter. When a self-commutated device is used as a switch, instead, if thyristor is used in its place, it is termed as step-up chopper. The variation of output voltage can be easily computed. There is a linear variation of current I1 and I2 during the time interval T on. So the expression during the time interval is given by I2 minus I1 is equal to I maximum minus I minimum is equal to Vs by L into on time. The current varies linearly from the maximum to minimum during the time interval of T off. So the expression for dis by dt during the time interval is given by I2 minus I1 equal to I max minus I minimum equal to V naught minus Vs by L into T off. Vs by L into T on is equal to V naught minus Vs by L into T off. Now the average of value of output voltage is V naught is equal to Vs into T by T off. Vs is equal to T divided by T minus T on. T off is represented by T minus T off. So Vs is equal to 1 divided by 1 minus T on by T. T on by T is equal to K. So Vs into 1 divided by 1 minus K. The K is the duty ratio. That value is in the range 0 to 1. The on-time interval on T on is equal to K into T. K is reduced because the minimum value is higher than that is higher than 0, and the maximum value is lower than 1. For this reason, which is also valid here, the source current is assumed to be continuous in boost converters. Thank you.